Hello guys, welcome to Red Exploit. So today we are going to see about BITM, which is browser in the middle attack. So this was quite discovered long back. I would say like in 2010. So but it is just widely used now as well. So it's not kind of a stale method, but attackers still use this BATM to bypass MFAs and other restrictions, like SSL stripping and all these things. So it's quite an interesting attack. So I got interested into it and I started exploring it, like how it is possible and what is the methodology to use this BITM attack. So now I've just created some POC and I also kind of creating a blog in Medium. So as you all know, like we used to blog in Medium. So I will also drop the Medium blog link in the description of this video so that you can go back to the Medium blog and read more about it. But to get an overview, so when we just take BITM, it's easy to understand when you compare MITM versus BITM. So MITM, as you all know, is man in the middle attack. So what you do is like you keep a proxy server, or you just sit in a network and try to analyze or just eavesdrop the communication happening in the network. But the BITM is there's a quite trick part in it. So the BITM is like if you hijack a browser or you control a browser and the victim traffic is being routed through your browser, so you can see all the communication happen from the victim to whatever the site he's visiting. So for the victim, it seems like okay, he's accessing his browser, but in the reality, like he is not using his browser. So it's like we embed a frame of our of what to say of a controlled browser, like attacker controlled browser inside his own browser. So it seems like victim uses his own browser, but in real time he uses the attacker controlled browser to access whatever we want. And the thing is like we can hijack the keystrokes easily, so we don't need to submit the form. So when victim starts typing this whatever inside this application, you can just try to extract it or fetch it easily. So this is the overview. So if you want to read more about this BITM versus MITM, so you can always go to my blog and see it. So I just want to let you know the architecture so that it will be easy. So I just want to just demo the POC which I have. So I just want to make this video as small as possible. So let's quickly jump into the architecture. So we have a victim here and an attacker control domain here. So what we have in the attacker control domain? So we have a VNC platform. So VNC platform is kind of an which like you just create your own virtual desktop kind of thing there, and we are just going to host a browser, a headless browser with a phishing site, so that we just send that URL as a phishing URL to the victim so that we can lure the victim on clicking the phishing link. So he will be landed into a VNC, what to say, like a browser with a VNC session. So that VNC session will be having our phishing site hosted in Chromium, which is a headless browser. So if the victim started typing something, because in the phishing site we will be having some JavaScripts, so which kind of fetches the keystroke and then sends back to our server, and then we can kind of log it somewhere so that we can use it for later purpose. So this is how the architecture looks like. So if I need to just break down some of the parts, so let's start with like we will be deploying a VNC environment here, and inside this, and then we have something called WebSockify. So WebSockify is nothing kind of a proxy which converts the traffic, WebSocket traffic into an HTTP based traffic. So why we are doing it? So in this POC, we have a VNC. which accept or which communicates through TCP, and we are just trying to host a web application, which is the phishing site. So the phishing site, it's kind of like it has JavaScript, and it grabs the keystroke of the victim, and it's tried to send those keystrokes via the WebSocket communication. So we need some proxy which converts the WebSocket communication into a HTTP based communication, so that like there is a frequent or like hassle-free communication happening between the VNC and with the victim browser. So that's why we need a WebSockify. So this is a proxy kind of thing. And once we have this VNC and WebSockify, so we have the environment where we are just going to have the phishing site ready for the victim, and this WebSockify is kind of a translation between those WebSocket communication to TCP. So now we need an important point. So we have a VNC server, but we need something kind of a utility to browse the phishing site, right? So that's where, like as we saw before, we are going to use this Chromium browser. So we are just going to have a Chromium instance running. Um, so that Chromium instance will be having the phishing site which is hosted. So inside the VNC, I would say. So if it looks like something like this will be hosted here. I can even show it in the demo. So the Chromium will be hosting. This is the phishing site which I created, which is kind of lookalike of OASP juice shop. Um, so now we have VNC server. Inside the VNC server, we have a Chromium headless browser running this phishing site. And so what does the phishing site has? So the phishing site has as like a JavaScript embedded into it. So we have Apache web server, which is hosting the phishing site. So this index.html is just a kind of a login page, which you know, looks like the OASP juice shop, and it has a reference or a link to the attack.js, which is a JavaScript which has the logic to get or fetch the keystrokes from the victim. And this attack.js fetches the keystrokes and sends it to our web socket server. So that is again a JavaScript which created, which has this WebSocket logic, kind of like spinning up a WebSocket server and listening to fetch the keystrokes. So, and this is the stolen credential.txt which will be created, and it will be frequently updated whenever the victim tries to do something, or just type something. So this is our kind of phishing environment looks like. So so once the victim, so what we'll be sharing is like, so we will be sharing the VNC URL as a phishing URL to victim. So once the victim clicks it, so this VNC environment will be shown like this. Like you can see, the web page which looks like OAS shop. And if the user enters username and password or email or password, so the keystrokes are grabbed and send it to the WebSocket server, and it will be saved in the stolen credentials. So this is how the stolen credentials looks like. As you can see, this username test and attacker, or it will be a bytecode in the WebSocket console logs, but we have tried to parse it, and then we're just showing it in a plain text. So and so let's just jump inside the environment, so it will be easy for us to understand easily. So let me show what I have. So as I mentioned, I already have a VNC environment which is up and running. So I have this Chromium instance here which hosts the index.html, which is the phishing site. So I can even show you the index.html how it looks like. So this goes like something like this. So as you can see here, this looks like a OS shop application, and then I'm just trying to trick the user into typing something here. So this is how it looks like. This is hosted inside the VNC. As you can see, I have created a VNC instance I have created multiple VNC instance for testing. So that's why it's three. I'm just hosting or like having a headless browser running this web application on instance 3 of the VNC. and here I just run my proxy WebSocket proxy. So it just listens on 6083, and it forwards whatever communication comes to this WebSockify on 6083 to the localhost 5903. So this is where my VNC instance is running. So it's like kind of pushes all the traffic to and fro whatever comes to the 6083. So then we have here a juice shop application which is hosted. So I'll just tell you why it is hosted here. So this is kind of a legit application. Consider this as kind of an Amazon or like whatever the target application you're just trying to trick the user. So this is the legit web application which is hosted on I think it's running on 3000 port, and this is the phishing site which is running on the Apache. Uh, like we have it in an index.html thing. So then what we have, so we have here the still credits.js running, which is has the logic for running spinning a WebSocket server and trying to just get all the keystrokes from the user. And this is where I'm just trying to see the contents of the stolen credentials.txt. So what we do is like let's try to just build a attack scenario. So I have a victim mission here. So what I will do is let me pull the victim mission, log in, just give me a second. Uh, uh, so guys, let me pull this victim mission here. Okay, this was okay. So this is my victim mission. So I will be just sharing this URL to the victim. Say consider this as a phishing URL. So if the victim clicks on the URL, he will be presented with this application. So this application looks like a legit OASP Jew shop, and we have some notification saying like we are currently rebuilding an application because it seems to be 80% or 70 to 80% of OASP Jew shop, but not exactly as OASP Jew shop. So let's so what we need to do now. So if you just go to our WebSocket thing, where was it? So this is the thing. So as you can see here, there is a new connection established, which means like the VNC thing, which already established here. So let me just minimize this window, so I think we can see it side by side, so it will be more easy. So let's have it like here, and this will have it something like here. Let's do it this way. Mhm. Okay, so what we need to do is let's keep a track on this area. We'll just say this area. Yeah. So let me just try to, okay, I'm a victim. I just got phished. I thought like, okay, something is happening with this application. So they just want to renew my username or something. So I just give it as, a POC 01. As you can see here, when I just start typing it, all the buffers are received here. So that's quite see, that's quite easy for us to just gather the credentials or even whatever we need, because we don't need to just submit the form. It's like we have the JavaScript running in our browser, which is like that JavaScript does everything for us. So when I just click login, so I just try to mimic it saying like login please wait, and then if the user clicks OK, and he will be now redirected to the original OS Juice shop. So this is just I made it to just tweak the real scenario. So that's why this OS Juice shop instance is running, because once the user entered his credential and clicked OK, so he will be routed to OS Juice shop, the real application. So he might think like, okay, some login issues happen, so I will just try to log in again and proceed. So there is no doubt like he's been phished or something wrong. So now if we go to the attacker site, so now we have this collection closed. As you can see, there is the connection has been terminated. And then if you go to check this credentials, stolen credentials.txt, now we would have got the keystroke, that's a username and password that's been logged in our WebSocket log. So, so yeah, we got this the victim's password. Now we can log in, or we can even do anything we want. It's this is just a kind of a simple POC, but we can just try to make it more realistic, like bypassing MFA. So why I say bypassing MFA, it's like if you are just trying to sit and view, we can even set a proxy in our attacker browser like a burp, where it forwards everything to burp. You can even try to manipulate or manipulate the request and response and try to trick the user, and you can even simply just kind of passively recon them, and once the successful login is happened, and then you can hijack the session cookie, and then you can try to replay it, so you bypass all the validations, basically captcha, MFA, OTP, anything you name it. So but this also has some restrictions, because most of the browsers comes with some restrictions to run this JavaScript and all this down. So there is some kind of defense which we can do it, um, kind of a CSP and all those things. So defense part is also covered in the medium blog. So I will just try to end this video here, to just keep it crisp and short. So hope you like this POC, and if you like to know more about it, or you just want to enhance something which I said, or I just made a mistake of showing how this BITM thing is, I got it wrong or something. So please put it in the comments on under the video, so that I can just enhance, or look into it and upgrade the content. So thanks guys, thanks for your time. So see you soon in another video. See you. Bye bye.